Hey there, I hope you're well. Welcome back to Verbose DevOps. Today I'm going to do a really amazing Terraform video. I'm calling it Zero to Hero because you can start knowing nothing or very little and you can get to a stage where you'll be pretty comfortable using Terraform, shouldn't have any issues and know most of how to do it, and if interviewed then you should be able to make decent answers also. So this will get you up and running, and also it has a lot of real world relevance. So here's the agenda for today. We'll do a quick explain of what is Terraform for those who don't know, then a hands-on demo. We're going to make some AWS resources. I'm literally going to show you exactly how Terraform works. We will cover the most important Terraform commands, and there will be quite a lot of them, and not absolutely everything, but all the important ones. And I'll cover also real world use, how people are really using Terraform, not theory only but also the practice. And after that, quickly cover some of the alternatives, pipelines, processes, complementary tools that are quite commonly used and you might even get asked about, as well as, yes, common interview questions as well. So first of all, what is Terraform? Top right, I made a short little example of some code there. It's the most popular IAC tool, infrastructure as code. If you don't know what that is, Google it please. It basically means that today in modern cloud DevOps, we're not pointing and clicking to make things anymore. We're doing it all as code, collaborating with our co-workers, reviewing each other's code, committing it to a repo and deploying it from there, etc. Now it's made by a company called HashiCorp. It uses its own language called HCL, and it follows the IAC principles. So it's declarative. It's about a desired state that you're specifying. You are saying what you want, you're not saying how to get there. And it's also idempotent, so you always get the same result because you're only telling it what you want. You're not telling it again how to get there. So Terraform should always give you the same result. No matter how many times you run it, it should always eventually give you exactly what you need. Now, one of the great things, this tool, when it was invented, was it's the same tool and language for multiple cloud providers, all big three cloud providers, and also other vendors. So if you work on AWS and then you have to start using Azure, if you've been using Terraform, then you should be able to switch from one to the other pretty easily. Yes, the resources will differ in how they work, but at least from a language point of view, you should be quite well prepared. It's a Golang program, so therefore it's a single binary, which is common with Golang, and that's super handy. You will see later. And it just uses behind the scenes regular API calls to the cloud or whichever other provider it's interacting with. That's how it works. You don't have to worry about those API calls. You just use the Terraform language and let Terraform take care of the API calls in the background. Now it's mostly copy and paste, as you can see in the top right. You're just configuring various settings and giving things names and that kind of thing, but there are some other similarities to programming in the workflow. As I mentioned, that you treat it like code and you try to keep your code dry and you collaborate and all that stuff. And there's also some programming principles like conditions and loops and stuff like that. So just to let you know. So the hands-on demo, let's get on with it. We're going to make 3 pieces of AWS infra. The first one is a bucket. It's called S3 in AWS. A bucket in all clouds is basically object storage. It's super common. We're also going to be making a virtual network, which is called a VPC. And we're going to be making as well something called a security group, which is, let's say, networking rules or laws that the network traffic must obey. And instead of being completely independent, this is actually going to be related to the VPC. Okay, so what do we have installed already? We have the AWS CLI installed. You don't need this, but this is an alternative to point and click GUI. And I also wanted to show you this at the same time today, because if you're not already using it, I do recommend it. It's really great for using with bash scripts as well. As you will see, I made a bash script, and also we've installed Terraform. So let's do this, and let me just escape out of here and show you. Before I open up my terminal, I just want to show you, if you just type on Google install Terraform, you'll end up with a couple of methods for whichever OS you're using, and typically will be a package manager or binary. Now, although a package manager sounds super convenient, the problem is it will always give you the latest version. And you're much better off using the binary and here is the latest version, but it's fixed. Or you can download from the archive older versions. Now, you would never know from here that that was important, but in the real world what happens is most companies will not be using the same version for all of their infra. They will be fixing the version, and sometimes old infra will use an old version and they didn't get around to upgrading it and that kind of thing. So I think it's super important that you download the binary. This is in the real world what people are actually doing. They're not using package managers. And in terms of AWS CLI or whatever cloud you choose to use, this is just downloading a zip and installing it. It is really, really quite simple. The other thing that I've done is if you go to type Google Terraform AWS documentation, then you end up with this. This is just to say that with our AWS CLI and Terraform, to get it to work and be authorized with my own AWS account, right? How does it know? We have to authenticate. And there's a number of ways to do it, and this page will tell you, but my preferred way is using environment variables. This is what you want to use in a pipeline for sure, but I also prefer to use it as well on the terminal when I'm just running Terraform myself manually. So in a pipeline, obviously, if you don't know, environment variables are a way to inject secrets without having them in your code. So that's why they're super important. So I've already done this step here of specifying an access and secret key and also a default region. So I just wanted to let you know that right off the bat that I've already done that kind of pre-step, okay? So let's go to the terminal here. This is my own private server that I've decided to install the CLI for AWS and Terraform on. You can do it on your laptop. They're not dirty tools or anything like that. I would strongly recommend it. But in my case, I've just decided to use another throwaway server. It's just what I like to do because I'm doing so many videos, or will be, that I don't want to clutter my laptop with 1,000 tools. Hope you understand that. So what I've done is I've cloned a repo called Terraform-demo. These are the contents. Let me show you how to get to that repo. So there's a site called codeberg.org. It's very similar to GitLab or GitHub, extremely similar. The difference is that I think these guys are non-profit, and also there's a community there as well, and a lot of quite big open source software is actually using Codeberg. I think they want to be less aligned. So I thought, why not try it? And let's set up a verbose DevOps site there. So you go to codeberg.org/verbose DevOps. And in there, what I've done is set up this Terraform-demo repo. Now, currently in this repo, you'll see I'm in the develop branch, but by the time you watch this video, I might have promoted that everything that's in here and promoted it to main. So just to let you know, you're probably not going to have to go to the develop branch within a few days. And here is the code, and you can just clone it here in the usual way. Git clone that URL, or use SSH if that's your preferred way. So that's enough of this. We will come back to this page later. Let's go back to the terminal. This is exactly just what I've cloned. Just before we start, I'm just going to temporarily move a file. This will become clear later on why I'm moving this. In fact, I've already just moved it. What I did was I moved a file called backend.tf, and I moved it to this to add. Okay, we're gonna pull that back out of there later. But when you clone this, you might want to move. You might want to go move backend.tf and stick it somewhere else, or just delete it and then clone again and get it back. This will become clear later on. Okay, so with that said, let's start looking at this code. Let me show you what is Terraform code here. If I do an ll for star.tf star, then you see that ending in .tf, we have a number of files. We have for infrastructure we're going to build vpc.tf and s3.tf, and then we have some more core reserved files which are provider.tf, variables.tf, and terraform.tf vars. I think the most important one is probably provider.tf, so let's have a look at that. Let me clear the screen. Provider.tf, and just using Vim. I don't particularly code this way, but I might be trying to learn soon and get better at coding that way. But I use VS Code mostly. But let's have a look, right? So you need this block, and Terraform is often composed of blocks. Terraform with braces, and this is a block that says that we're using AWS, and a provider is what Terraform calls the cloud or whatever it is that you're interacting with. And it's basically a plugin, and by putting it in here, this is how it's able to download the plugin and issue API calls to AWS and work with it and build out our infrastructure. It's absolutely essential, and I have pinned a version here which I strongly recommend that you do. You don't have to, you can just say greater than 5 or something like that, but I strongly recommend that you pin the version because there are differences. So in this case, this is the latest version. Let me show you how I got this info, by the way. If I go back here, we go back to the docs here, okay, then AWS documentation, at the very top it says providers. If I click on that, oh, it's actually, I think it's actually the same page that we're on. Yeah, let me just scroll to the top, and it says AWS provider, and it's got example usage, which is exactly what I've done here. And it just requires you, it says here, so you can just copy and paste this. It's even got a button there to copy. And you see here the example they give you is to say that it should be greater than or equal to 5. So it should be pretty much the latest. If I go right to the top, you see here on all the documentation pages, you always want to make sure you're on the right version. Here it says latest, but you see we're on version 5x at the moment, and 5.57.0 to be precise. So in this case, what it's saying is be on pretty much the latest version. You know, greater than 5, then it should be happy with that. I recommend that you pin the latest version like I have done in my code. I personally think that's better. So that's very important. Now, and let's it do the API calls. Now let's have a look at one of the files. So I'll just give you a reminder what we have. Didn't really need to clear the screen there, but vpc.tf, let's have a look. This is where we're going to make our VPC, and you can see here we've got a block. Okay, ignore this stuff for now, I'll explain that later, but create a VPC, that's my comment. You can use a hash for that, or hashtag, whatever you want to call it. And you've got resource AWS VPC, and then a name. This can be whatever you want. This is normal for all Terraform, so I've called it VPC 001 because it's going to be my first VPC, and I might make more later on down the line, and doesn't have a particular purpose, so I called it 001. And in here I've decided to add one parameter, which is sitter block, and I put something there. I'm going to come back to that later because obviously you don't see a value for the sitter block. Let me show you the example for this in the docs. This is very important actually. So if I go AWS_VPC, oops, it's a little bit slow. And I've got to scroll down because that's actually referred to in a lot of different places. So let me go all the way down here because it's actually used by a lot of other resources. So I'm looking for VPC, TUV, VPC, Virtual Private Cloud, right? So let me click on the one I was talking about. Now the thing is, right, if you know you want to build a VPC in AWS, if you just go to Google and type in Terraform, registry, AWS, and then VPC, you will get the top Google hit will take you straight to this page. It might be on the wrong version. You got to make sure you're on the latest one, or whichever one you're using. That's the only thing to look out for. But otherwise, it'll take you straight to this page. What I just showed you on the left was just a way of doing it through the document route. You know, another way to do it. And so look here, there's a basic usage, and I basically copied this to say that we want to set one parameter or one setting, which is sitter block. In this case it says that. In my case I've done it slightly different, which I will explain. And they always show you on these documentation pages some basic usage, which you can see here. So it's added, in this case, a tag, and then it typically shows you a more advanced use case like using IPAM, so you're doing some other stuff. We're not going to go into data resources, we're only going to cover normal resources in this video, so that's something else. So here it will always list, these are the arguments that you can use. Now sometimes there are required arguments, in fact many times there are, but for this particular resource, AWS VPC, they're all optional because it's starting with optional, okay? So the first one is the one I decided to use, but it's entirely optional. I didn't even have to do anything. So it's showing lots of optionals. Now in many cases there is a default value for a argument. If you don't specify it yourself, it will assume some kind of default, and in this document it tells you that the default is default, for example. Or in another case, if I go down here, enable DNS support, the default is true. Okay, now this is very, very common. Now if I go down here, there's also something called attributes. And what it's saying is that when you make a resource, it will export some attributes. It will also export the arguments above, okay? So what this is saying is, it's saying if you make a resource, there are basically, I don't like to use the word attribute, I like to use the word, I think properties is a better word, but there are properties of the resource that you create that will be available to you to use. Now, the most common on AWS are the ARN and the ID, and there are similar ones on other clouds. And basically these are identifiers. So one is like a kind of Amazon address for your resource, an ARN, and the other one is an ID, which will typically be a kind of like a name, okay? So ID and ARN are super popular attributes to be exported. In fact, so much so that if we look down here, I've actually said I want to output the ID, I want to output the ARN, and I also want to output, just to make it clear to people, they don't have to go fish around in my code, I want you to output the sitter block that I entered earlier. And do you see the way these are referred to is that you got the resource and the name and then the attribute. So the resource type, the name, and then the attribute. That's how it works. So that's what we'll expect. This will be more clear when we start running the code. So let me come out of here, and we're going to go look at another file now. In fact, we're going to go look at that variables file because it makes it more relevant what we've just seen. So these are our variables. We got region, which is, I put it there because it's super common that you put your region here and you might end up needing to use it again and again and again for making resources that need you to specify a region. Instead of typing in US East 1 every time, you can use a variable. And for the VPC resource that we just saw, I actually made a specific variable for the sitter block VPC 001 because it's convenient that I can just substitute it. Now, look here, all we've got really here is a list of variables and the type. We don't have anything else. And I want to show you how these are specified, okay? So let me just come out of here. And you see there's a file called terraform.tf-vars. So, by the way, variables.tf is a very common way to refer to it. But actually, I don't think you have to use variables.tf. You could just stick it in vpc.tf. Pretty sure about that. Not 100%, but I'm pretty sure. It is just convention anyway. You'll see 99% of people using variables.tf. So, terraform.tf-vars. Let's have a look at this. So, what do you know? Those two variables we were just looking at, you can in here see the assignments to those variables. And we've got here US West 2, and I wrote that in there. And for the sitter block, it's just like that example in the documentation, 10.0.0/16. I have specified it here. So in the variables.tf, you list your variables, and in terraform.tf-vars, you list the assignments for those variables. Now I know what you're thinking. Why use two files for that? Isn't that kind of crazy? So first of all, thing to know is terraform.tf-vars is this Terraform part is a special name, and it's run by default. If you don't do that, then when you start using these commands like terraform plan, you're going to have to use this -var-file equals and whatever your other name is for your tf-vars file. That's what you're going to have to do. So, okay, great. So terraform.tf-vars, we're using it. The name makes it super convenient that we don't have to actually put in var file. But you might still be wondering, why are we separating out into two different files, the variables and the variable assignments? So I'm going to explain that to you. Why would you ever want to run like this? The reason is that you can run multiple different tf-vars files, and you run them by specifying like this. Now you're probably wondering, why would you want to do that? Let me show you. Here is an example in another repo. Just want to let you know this is using the MIT license, okay? And if we go to enms, and this is very common in Terraform, that you store your tf-vars, multiple of them, in a separate directory called enms, and you use a different tf-vars for different environments. Extremely, probably the most common use case for using a different TFR files. And that way you can run your Terraform commands and specify a different TFRs file. And that way you're saying, this is my infrastructure for dev, this is my infrastructure for prod, and this is my infrastructure for stage. Now why would you do that? Let's have a quick look at one of these files, right? Typically you will have in there a description of the environment. That's pretty normal. But what will differ from one environment to another, for example, you may probably have different, if not VPC, then different subnets for your different environments. And this is an opportunity for you to put them in here. Another really extremely common reason is you may have a lower number of resources in dev compared to production. Production, you have a high load. In dev, it's just for internal testing. So here, for example, we've got, this is for an EKS cluster or a Kubernetes cluster, we've got only between 1 and 3 nodes. Now, if I come out of dev and go into prod, remember there was between 1 and 3 nodes. Oops, sorry, that's stage. Let me go to prod. If we go to prod, then you'll see it's between 3 and 5. It's more nodes. So this is a very common use case. And the overall, and I think the subnets are different as well. And the overall theme here is that your underlying, all your TF files, like here you can see some TF files, they're all the same. And the basic infrastructure between your 3 different or more or less different environments is going to be the same. And that's what you want. You want parity between your environments. This is a very normal concept in cloud DevOps. You don't want different environments looking different, because if you test something in dev and dev looks completely different from prod, then what was the point in testing it in dev? You're going to end up going into prod. You got no idea what to expect because your infrastructure, everything is totally different. There was just no point in testing things out in dev. So you want your different environments to look similar. However, there will be some tiny little differences, such as different subnets or number of resources to save money in dev and that kind of thing. They will be not significant to your application. Your application will still behave the same in the different environments, but they will just be for other reasons like saving money or whatever. So that is pretty typical to have dev be a lot smaller than prod, for example. Classic use case. So I hope that gave you a good idea of why you would do that. So let's start coding now, shall we? Actually, before that, let me show you the S3 code. And in here, what we're going to do is we're going to make a resource, an AWS S3 bucket. Now, I just Googled Terraform, AWS S3 bucket, and it came up with that documentation page that we need. And here we're going to give it a unique name, and we're also going to give the bucket a globally unique name, which is the rules of buckets in clouds. They have to be globally unique. I'm also just going to give it some tags. Let me explain this a little bit. So in this case, I'm calling this S3 Tesla, and I'm pretending that I am the Acme company, and we have a bunch of buckets. And what we want to do is we have multiple clients, and one of our clients is Tesla, so this is the bucket for them. Okay, and also here I'm putting some tags. Tagging, if you don't know, very common in cloud DevOps. You should really tag everything, because for costing and other reasons it's going to come in super useful. And name and environment are very common tags, and you probably will have things like department as well, but in this case I'm saying our environment is dev, just as an example, and the name here is Tesla. So just an example, nothing more than that. And I actually created here 2 output variables. I want to know the ID, so that's the attribute.id, and I also want to know the ARN as well. And that's the purpose of these 2 output variables. Will become clear as I start to use these commands, how they work, and also when I get into modules. So let's do a Terraform init, which is always the starting point. So in fact, let me clear the screen first, because we may need to scroll up, and that's going to be handy. So you can see some stuff happening here. The page will probably scroll in a second, but I will explain the first one, which is initializing the back end. So the way that Terraform works is it keeps its own copy, and I will show you this later, but keeps a copy called the back end or the state file. It keeps a copy of the infrastructure that you have deployed. And the idea is that when you make a change to infrastructure, you change a parameter or something like that, and what it will do is it will check and keep up to date this state file, the back end, and it will check by looking there to to see if you're making a change or you're not making a change. I will explain this later. The main thing you want to see here is it's initializing the provider plugin. So it's installing HashiCorp AWS version 5.570, which is what I asked it to do. This part here about the lock file. Now, a lock file is just a way to pre-declare that these are my dependencies. So I have a lock file from previous use, and it is good practice to actually put this on your repo. However, most places I've worked at have not done that at all, but I believe it should be a bit quicker, and also it is best practice to actually check in the log file. So when it says reusing, that's just a notification. Don't worry about that. The main thing is that it's initializing the back end, because it's making it for the first time, and it's also installing this plugin. Now let me show you again the files in here. And okay, great. This looks good to me. So let's do now a Terraform plan. Again, this is a very core command. What we're going to do is plan. From the name you can tell we're going to plan our infrastructure. So let's see what it does. Okay, great. So you can see it's come up with basically what I've called a plan. So what did it actually do? It talked about using the provider to generate an execution plan, and it will tell you what it's going to create. Now, this is from scratch, there's nothing there, but typically you might see something like we're going to delete this or destroy this, or we're even going to modify something. But when it creates something, you always get plus sign and green. If you delete something, it's red. If you change something, it's yellow. So in this case, it knows that we want to create an S3 bucket Tesla, and it can see some of the parameters that I specify, like the bucket name. It's also assumed some other parameters like force destroy equals false. Now, it assumed that. I didn't tell it to do that, but this is a default value. And there are other, let's say, attributes here that will only be known after apply. Some of these will be in fact, most of these will be defaults actually. And you can see here these are the tags that I specified, and it's saying this is what will result. So let me go down. And there's a whole bunch of known after apply. Let's go to the VPC, and here it said this is the resource that you asked for, and this is the sitter block, and this is the default value that we know right now already we're going to assign. That enable DNS support will be true, and instance tendency will be default, and all the other ones will be known after apply. So that's quite normal. Plan is 2 to add, 0 to change, and destroy. And it also, even at the plan stage, will make reference to those outputs that we specified. Okay, so it was the RN and ID for the S3 bucket, and also the VPC, as well as sitter block for VPC 001. Right. Now it makes some mention about I'm not using a plan file, and it's saying, look, if you go ahead and do an apply now, which is what we're going to do, it says we can't guarantee it's going to take the above actions. And let me demonstrate that to you. If I now do a Terraform apply, you're going to see exactly what that's talking about. And let me scroll up. And it's saying, basically what it's done is it's actually done the plan again. It's saying, okay, well, here's the plan again. We're rerunning the plan. As it happens, it's identical, but that wasn't guaranteed, okay? And it's saying the same thing, what it's going to do. And it's saying, do you want to do these actions? And then type yes. Now I'm going to say no, because what you have there is you actually, this workflow generates 2 plans. That's not what we want. We just want one plan, and we then want to apply that plan, and that is better practice. So what I'm going to do is I'm going to take the first suggestion, which is to say Terraform plan. However, I want to do out, and I want you to create a plan file. So here we go. And you can see that I won't scroll up. It's basically done the same thing, except it just says save the plan to plan file, and it's even telling you how to run that plan file. And we don't actually need that quote. So let's do that. Let's clear the screen. Oops, that's not how to spell clear. Terraform apply plan file. Great, fantastic. So you can see here that for each resource it told you creating and then when it was complete, and it's even actually returned the ID, and this is quite normal. And it gave a summary 2, added, zero change, zero destroyed. So that's great. And also showed the outputs. This is what we asked for, to give some output variables, and you can see them there. There's actually another way, by the way, to show those output variables. You can do a Terraform. I think it's outputs. No, it says, did you mean output? Indeed. Let me just clear the screen. Terraform output. And you can get the same thing as well. I believe it didn't grab this from AWS. It's grabbing it from our state file, which I mentioned before, which we are going to have a look at now. So let me just show you. Let me clear the screen. There's a new file you may have noticed. Oh, by the way, when we did a Terraform init, it put the plugin for the provider in there. You never need to go in there. There's a lot of junk in there, so just ignore that. But look at this. There is a file here called terraform.tfstate, and that is a state file. So it now has a record of the infrastructure in the state file. In fact, I'm going to show you the state file. Now, the state file should be protected. Be aware that it can sometimes store secrets, such as initial database passwords and stuff like that. So that's just a warning to you. But in the state file, you'll see that there's a Terraform version. So it's very important that you always use the same Terraform version for your state file, and there is a way to upgrade, but that's why I recommend don't use a package manager for installing Terraform. And look, it's got a list of the outputs that it discovered earlier, and it stored them here. And then it's got the resources, and it's got them in this really nasty kind of, extended language, or whatever you want to call it. So what the point of the state file is, when you build something, it stores extended information about your resources in here, and it uses this later. So for example, let's say I haven't changed anything, right? But Terraform doesn't know that. So let's say I do a Terraform plan. You see what happens here. There we go. So no changes. Now let me explain what happens here. Every time you run a Terraform state, there's a Terraform plan, there's a refresh of the state. Now you didn't know that earlier because we didn't even have a state before. We had nothing. So what it will do is it will look in the state file, which has two resources from earlier. It put those in there, and it's just a record of what we made. And the first thing it will do is refresh the state. So it will go out and look at AWS in the real world. It will look at AWS. It will look up these resources. It will find out what all the parameters are, and it will update the state file. The state file is our local copy of the real world infrastructure, but only what we have built with Terraform. So it will, when you do a plan, it always refreshes the state file. It updates it to current. And then what it does, and it doesn't show it here, but it looks at your configuration. And it then compares your configuration, the state file and the configuration. It does a comparison. Remember, the state file has just been updated. So the state file, we're going to call this up to date. So it takes the up to date state file, compares it to your configuration, and if they are identical, it will say no changes, your infrastructure matches. However, if they're different, it will say you want to do a change, and this is the plan, and are you sure? Do you want to apply it? But in this case, no changes. Your infrastructure, which is in the state file, matches the configuration, which is in all your TF files. And it just summarizes that. Terraform has compared your real infrastructure, the state file, updated, against your configuration, the TF files, and it found no differences. So no changes are needed, and it won't do anything. So I hope that gives you a good understanding of how that works. Let me show you here, by the way, while we're at it. You can actually, there's another way to look at that state file. Instead of all that garbage that we saw, you can just type Terraform state list, and it will only list out those resources. It will ignore the output values, it will ignore all that extended information, and it will only show you this. This is quite good for putting into scripts and stuff. It can be quite handy. So there you go. Another thing that you can do is, let me clear the screen, Terraform show, and let's see what it comes up with. Now this is kind of similar, I think you'll see. It's kind of similar to the plan file, or even when we did the apply. It's very similar. So it shows the resources and all the different properties or attributes or whatever you want to call them, and it shows the outputs. Basically, it's getting this from the state file. Even though this command is Terraform show, it's actually using the state file. So those two commands were Terraform state list for just a small list, and Terraform show for the bigger list. Even though it doesn't have the word state in it, they're both getting things from the same place. State list just shows a summary, and show is like the entire state but in a human readable format. So that's what those two things are. Okay, so let's clear the screen. Right, so I'm going to show you an example of when we modify something. Okay, and yeah, let's see here, something that we might modify. So I am gonna go to the documentation here, and I'm gonna show you here this. Let's pick something here that we can use as an example, and I don't know. I'm gonna add a tag to it. I don't think we had any tags, so let's do that. So let's go and modify vpc.tf, and let's insert here. Let's paste this in. There we go. We're gonna add a tag called name equals main. Pretty useless tag, but it doesn't really matter. So let me escape :wq right quit, save that, and let's run a Terraform plan. So first of all, it's refreshing the state with the real world, and it actually didn't have to do that because we know that there were no changes made. Nothing else happened to these resources. We didn't change them, nobody else changed them. And then what it did was compare it with our configuration in the TF files, which we just edited, and it noticed a change. It noticed that we have added a tag. So it says here that we are going to change the resource. So that's what this symbol means, update in place. So update that resource, but add the tag name equals main. And so the plan is nothing to add, but we do want to change one thing, which is that resource, and nothing to destroy as well. And so we can go ahead and apply that. You know what? I actually forgot to do a plan file, but so let's do it properly. Out equals plan file. And we got the same thing that we had earlier, so let's now do a Terraform apply plan file. And you can see it's modifying and it's showing us the ID of that resource, the VPC dash, and 3 seconds it took, and congratulations, it's all in green, which is usually good. And it also includes the outputs again, because they may have changed, but in our case they did not change. So we have now being able to change our infrastructure. And if we were to do a Terraform plan again, then you'll see something slightly different. I think you should know what to expect here, right? So again, it's refreshing the state, which is normal. However, we're getting your infrastructure matches the configuration because nothing changed. So I will just show you very quickly what it looks like if we revert that. So I'm going to just delete that and right quit, and again do a Terraform plan. Oops, looks like I made an error there. See how it actually does some validation before, which is pretty cool. I forgot this extra brace, I left that behind. Let's take that out, and let's just do that again. Terraform plan. I forgot to do the out file again, but whatever. And there you go. It says this time it's still updating it. However, we want to remove these tags, and you get this red minus. Now, By the way, it's not destroying anything. It's just changing that resource. We're not actually destroying altogether any resources. So just something to bear in mind. So let's apply that. And there is a switch, by the way, for auto approve on an apply. However, you know, I mean, we could use it, but as you can see, that's really only for quick and dirty scripts. You ideally should never use auto approve. You should be using a plan file instead. So great, we're back to normal now. So I hope you can see what it looks like to make an infrastructure change in Terraform, the kind of thing that you can expect to see. So something I want to show you as well is what happens if we modify an attribute outside of Terraform. Now, if you're in a company and you use Terraform, everybody needs to use Terraform. You cannot have some people making changes in another way, like using the mouse to point and click. Because what happens is they make a change, and your code, or when you use Terraform, when you use Terraform, the principles of infrastructure as code is that the code is the single source of truth. There should be no other changes. And if somebody breaks the rules that you've set in your team and starts to change things, then you're going to be doing Terraform, and it's going to say, hey, look, you know, what's going on? The infrastructure has changed and all this kind of stuff. You cannot work like that. And I want to give you an example of how that might happen. And you might do it intentionally. Maybe you need to do it for a test or debugging or something, but in general, you should never use it. So let me show you here. I've got some commands saved here. These are CLI commands for AWS. I've got some here for listing S3 buckets and DynamoDB tables and also VPCs and security group. We're going to look at that later, right? But the one I want to do right now is this one here. I want to what I'm going to do is describe the VPC, and in particular I want to describe this parameter, this attribute we looked at before, and by default it's set to true. However, we're going to modify this now using the CLI. It could easily be done point and click, and we're going to modify this to false. So let's get that VPC ID first. Let's go back to the terminal. So we need, in fact, what's a good way to get that? Terraform output. There you go. There's a VPC ID. So let's copy that. Oops. Copy. Let's go back to here. Let's put that in here. So I'm just going to enter that, and I'm also going to execute the second command, which will describe the attribute. So let me clear the screen first. I'm going to put that in there. So we're going to describe the attribute enable DNS support on this VPC. Let's see what it says. And there we go. It's currently set to true. So let's set that to false. Okay, let's go back. Let's get this little thing here. It could just be done by point and click if you wanted to, but I choose to do it this way. And let's put that in. We're setting it to false. And it doesn't give any output, but that's normal. So if I replay the other command to describe, it should be a difference now. It should be set to false. Great. So this is someone modifying a resource outside of Terraform. Now, what does Terraform think about that? Let's clear the screen. Let's do a Terraform plan again and see what it comes up with. And let's do, just in case we decide to apply it, let's make a plan file as well. So, because I keep forgetting that, and now I'm not forgetting it. So, refreshing the state, you know all about that, right? It always wants to get an up-to-date version of the infrastructure. And you can see why this is so important now, because we've made a change outside of Terraform. So the first thing it needs to do is, hey, did someone use a CLI? Did someone use a graphic user interface? Did someone start modifying stuff? We better first update the state of the VPC and our buckets and anything else that are in Terraform. And it detected something different. See? It detected that it has been changed to false, which is what we just did. And what it wants to do is convert it back to true, which is in our code. So it's proposing this change to update in place, change from false back to true. And it's saying that there's one resource to change, which is this change that we just described. So let's go ahead and do that. So you can see how awesome it is that it knows that something changed. It's using that plan file, the execution plan, it's modifying the VPC, and this is a very quick change. It's not like it has to build machines or anything. And okay, it's taken a little bit of time, but there you go. It didn't take too long, and it's done. And I can even replay that old command, which this one here. It should be back to true. There you go, back to true now. So, I mean, we can trust Terraform. We don't even need to run this command, to be honest. But it was just kind of a nice way to demonstrate things. So, yeah, that was that. So, I want to talk now about a couple of commands, and you typically might put them in a pipeline, and they're commands that come with Terraform. So one of them is Terraform format. Now what this will do is it will lint the code. It will make the code tidy according to some principles. Now it's not perfect, and I believe that there are other linting programs that are better than this, but you just kind of get this built into Terraform for free. So let's see what it does. And it did nothing. Basically, if there was something weird about one of our files, it would have corrected it. Let me give you an example, right? If I go vpc.tf, now what I'm going to do here is I'm going to make a little modification, and I think this is allowed. So let me press I to insert or edit, and let me what might be a good thing to change. I think I can do something like maybe add a space there, and we'll see if it corrects it. So let me right quit. Let's run Terraform format again, and you can see it modified vpc.tf. And if we go back, there you go. In fact, the cursor is still there, but that space, I added a space there. It put it back. It prefers to have only one single space there and not the two like I did before. So that's pretty cool. Now the other thing that you can do as well is there's another command. So FMT format is for linting. There's another command called Terraform validate, and what this will do is it will, before you even do a plan, let alone an apply, but before you even do a plan, it will validate that your code is good and doesn't have like syntax errors. So run this. Success. Configuration is valid. If there was some big error in our code, then it would let us know. I mean, I might try and recreate one, and yeah, what I can do, for example, is I can let's see here. Oh, I mean, I can take out one of these, right, and do a right quit, and then validate, and there you go. Look, it says that the configuration block was not closed properly on line 6 because there's no closing brace, and actually that also screwed up everything else that came after it because I had not fixed that. So I wonder if Terraform format will fix that. I don't think it will, but let's try. No, in fact it gave the first error, so that's pretty interesting. That's kind of interesting to see how it works. So let's modify this back, and yeah, let's put that back, that closing brace. In fact, before I do that, let me just quit out. What I'm curious to see is if I clear the screen, does Terraform plan catch that error? So what happens is, sometimes you'll run a Terraform plan and everything looks fine and dandy, and then you'll run a Terraform apply and it will say there's a problem. But when you did a plan, Terraform didn't catch it. And sometimes the validate can save you. Sometimes the validate will catch it for you. So I want to see, okay, when it did the plan, it actually knew. Just like validate, it actually knew. So that is kind of expected, to be honest. Let me fix this. Let's put this closing brace back in. So you can see the validate is not all that useful. It will sometimes catch things that the plan doesn't. So, but often the plan will just catch it. So you can see why If I invalidate, it should pass. Yes. But you can basically see what I'm trying to tell you is Terraform format, or FMT, and Terraform validate are not frequently used by most engineers that I've met. They know that you're supposed to use it, but they kind of just forget to use it. So it's actually better, or one thing you can do is you can use scripts, or you can use a make file, which is similar, to put your Terraform commands in. And that way, instead of typing Terraform plan, apply, validate, format, you can actually use scripts and put those commands, the format and the validate. You can put those in the scripts or in a pipeline, of course. And that way, it safeguards against people being lazy and not bothering to use those commands. Because I guess they don't use them so much because they're not so useful, but they're still useful, and really you should use them. And if you're building automation, I would recommend that you put those things in there. Okay. So that's format and validate. Now, what I want to show you is I want to show you destroy, which is a command. So let's clear the screen. Oops, that's not clear. So Terraform destroy. We'll see what this does. Obviously, well, similar to the plan, it will update the state with the real world first. So let's just go to the top. So just like the plan, it will first make sure that whatever you've built with Terraform previously, it knows the up-to-date, how it looks out there in the real world in AWS Cloud. And then it will say, okay, well, actually what you have is the same as what's in the real world, and you've instructed me that you want to destroy it. And this is what is going to be destroyed. And it's got all these red minus signs all over the place. Destroyed, destroyed, plan, 0 to add, 0 to change, 2 to destroy. Do you really want to destroy? There is no undo. Type yes. I'm just going to say no. Destroy, cancel. So that's how you would destroy. Now, I don't know if you think about it, there's another way to destroy. What you can do is delete all your configuration files. So for example, let's say I go, I'm not going to delete them, but I'm just going to move it. I'm going to move it to, I'm going to rename it back, tf.back, and I'm going to do the same thing for S3, and I'm going to rename that also back. So if I now do a Terraform plan, I'm not going to specify an output file because I'm just going to show you the plan, and you'll see what happens here. What are you expecting? I basically just deleted the configuration files. The Terraform doesn't see any infrastructure, so I've said that we want 0 infrastructure, and it gives us the same thing. It says that you want to destroy that S3 bucket, and if I go down, it says that you want to destroy that VPC as well. So there's 2 ways to achieve the same thing. And actually, it is better to do things this way than to use Terraform destroy. Terraform destroy is really, it's a human operator command. It's nothing that you would ever, well, you could put it in a pipeline, but it's not really recommended. I think if you're following IAC principles, it's better to actually set your single source of truth, or set your configuration that you want Terraform to read, set it to be nothing, and that would be better. So what I'm going to do, I'm just going to revert that. So move s3.tf.back back to s3.tf. I'm going to move the other file, which was I think VPC. I'm going to move that back to vpc.tf. And I am actually going to run the Terraform destroy command just so you can see what it looks like. So let's see what happens. Okay, so we've read all this before, and the only thing that we didn't do last time was to type in yes to destroy, so let's do that. Let's do a yes. And you know, it's pretty simple. I mean, destruction doesn't take very long, which is kind of cool. It only took 2 seconds for everything, and yeah, you can expect it to be quick. If it's bigger things, sometimes with big cloud resources, it will the cloud will tell you that they're deleted, but in the background the cloud is still busy deleting it, but you don't have to worry about it. So destructions are usually pretty quick. And yeah, destroy complete in green and looks quite happy. So there we go. Now what I want to show you next is, you see, in the real world, we have been using this file here called terraform.tfstate. By the way, it stores a backup, but we have been using this. We call that local state, or a local backend. However, that's only ever done for demos like this, or just learning Terraform for the first time. In the real world, in companies, you will never use that. You will always use a remote backend. You will store it, typically in a bucket in the cloud, or if you're not cloud, you might put it on a file share, somewhere that is remote, somewhere that is centrally accessible by multiple engineers, somewhere where you're performing real backups, not simply copying a file in the same location like you see here, but real backups, and also using versioning. Because if you lose a state file, it's super pain. You really don't want to lose it. You don't want to corrupt it. If you use the wrong Terraform version, sometimes you can even accidentally upgrade it when you don't want to do that. So in cloud storage in a bucket, you can turn on versioning, which means you can roll back to previous states of your state file, which is really, really cool. So I'm going to demonstrate that to you, but first what we need to do is we need to remove some files. So we need to remove terraform.tfstate, we need to remove terraform.tfstate.backup. We also should remove something else as well. I think that will do for now. What I'm also going to do is I'm going to remove this .terraform, okay? So I'm going to have it re-download to providers. This part might not be completely necessary, but the thing is, right, so I need to do it because it's a directory RF, and there we go. I'm going to remove that. The reason I'm removing this is because this was created at initialization, and I'm going to reinitialize. And the reason I'm going to reinitialize is because when we create a backend, a remote backend, that also needs to take place. So I'm just going to remove that as well. I think it's just better to do that. Now, what I'm going to do now, for the purpose of this demonstration, is I'm going to move a file from this to add, which is when you clone the repo, it's in there, and I'm going to move a file called backend.tf. Oops, I forgot to give a destination. Let's say current directory. There we go. Right, let's have a look at backend.tf. See what we got here. So to use a backend, a remote backend, a remote state file, I already said that typically it's stored in a bucket, and that is extremely common with all clouds. It's stored in a bucket. There is an additional step I will tell you in AWS, and that is you also need a database table in DynamoDB, and the reason for that is because you need to lock the state file. When an engineer is using Terraform needs to obtain a lock to hold that state file for its own use and prevent other people from also accessing that state file. And although all buckets across all clouds seem equal, they're not. AWS's bucket has a limitation in terms to do with locking, and that's why we need this also extra step. But anyway, don't worry, it's still simple. So we're going to configure this. We're going to say our backend is on S3, which is on AWS. We could actually stick it on Azure if we wanted to, but no, we're going to stick it on S3. And this is going to be the folder structure. So this is pretty common. We could just call it and stick it in the top of the bucket, Terraform or anything else .tfstate, but we're actually going to put it in here. And the reason is that you'll see in companies, this is quite common. You'll have one bucket, okay, for all your state files, and you'll have multiple state files for different environments, for different projects. So I've just given an example here. It could be stored in project 3/dev, and we're also going to put a region as well because we need that. We're going to encrypt this, although encryption is actually built in by default now in AWS, and yeah, there we go. And we're going to need a DynamoDB table. So we need a bucket and a table. So I'm going to quit this to make this. Now, what I've done for this is I actually have two shell scripts, two bash scripts, to create a backend, remote backend in AWS, to create or destroy. And you may be wondering, why am I not doing this in Terraform? And it's a chicken and egg situation. If I don't have a backend already, how am I supposed to create a backend in Terraform? I'd be using a local state file, right? Now, some people do that. They use local state files and run Terraform by hand to create their state file buckets. some people do it in other ways. They may have another state file just for creating state file buckets. Gets kind of crazy. We're going to use a script. I want to show you the script. So let's have a look. So remote and create. And here's what we've got. And don't worry about this. You don't really need to know, but I thought I'd show you. The first thing we do is create a bunch of variables. Okay. The state bucket name and DynamoDB. I've added some randomization in there, just so that every time the script is running, it will be a completely new one. I didn't have to do that, but I just thought I would do that. And we're also going to store these variables so that they can be used later on by the destroy script, which is what I've said there. Basically, what we're doing, if I scroll down, we're creating an S3 bucket and a DynamoDB table. So we're using the CLI to create a bucket. We're going to block public access. We're going to put versioning on the bucket, which you definitely need. Many companies forget to turn this on. You must do this. Otherwise, there's no point really having a remote state. If you lose that file, you can't get it back. And we're going to create a DynamoDB table. And this is all in the Terraform documentation. There's certain things like attribute name has to be lock ID and that kind of thing. So that's what we're going to do. And finally, we're going to list the bucket and the DynamoDB tables. And also, this script, very nicely, what it also does is, with the bucket and table that we created, it is going to modify that file we were just looking at, that Terraform backend file. And it is going to insert the bucket name and the DynamoDB table. If all this works, that's what should happen. So let me quit this. And well, I was going to say we're going to kind of pray that this works, but you know, I'm pretty confident. So what are they called? So here's the first one. Let's do this. I've already done a chmod to set the executable bit on, so we don't need to do that. Let's do create. So fingers crossed. Here we go. That's good. That's great. That's also good. Okay, great. So what it did was it did the creation and spat out some output, and then this is what I asked it to do later on, which is to list buckets, and it's created this TF state bucket that we asked it to do. There's the randomization in the name. It's created also the lock, the table that we needed. This extra bucket, don't worry about that. That's just a test bucket I did a couple of hours ago, so you don't need to worry about that. So let's have a look at backend.tf to make sure that it got modified by our script. And there you go. Look at this. Bucket is now populated with that bucket that we made. DynamoDB table is now also populated. Fantastic. So let's quit this, and what we're going to do now is we're going to do basically what we did before, which is a Terraform init. So initializing the backend now. We've got a remote state now. You see that? It's successfully configured the backend S3, which is the one that we defined. And the rest you've seen before. It's initializing the plugin, so it is having to download all those plugins again. So you know, this will take a few seconds, but I'm super stoked that the backend was successfully configured, and you know, the rest you've already seen before. So we can now proceed and do a Terraform plan just like we did before. And let's not forget that we need to do a out equals plan file. And there we go. And we know what these two are, two to add. It's the same as before, right? It is the Tesla bucket that we called it, and also VPC 001. And you know, when you start using Terraform, after a while, you often just, sometimes you need to inspect this super closely, but other times you don't need to. You know you don't need to. You just scroll down, look at the end, and just make a quick check. Is this what I expect? Especially that I'm not destroying anything, especially if you're working on production and you're changing things or adding them. You know, you always look at this line that you're definitely not destroying anything, okay? So let's apply the plan file. There we go. And this shouldn't take too long. You see that part there? Now that is new there. Acquiring state log. Did you notice that? I think that's new. I don't believe it happened before, because it's especially relevant for using a remote state, a remote backend. That's exactly why we set up that DynamoDB. AWS forces us to do that. When you use a remote backend, and it could be multiple engineers working, it's very important that you acquire the state log. Anyway, everything looks perfect. So what I want to show you next is, if we look now, I clear the screen and do a directory listing. We've got this back from the Terraform init, but if you notice, there's no TF state file anymore, and that's because we're not using, of course, we're not using a local state anymore. We're using a remote backend with a state file stored in S3. So yeah, I think you can see that's pretty awesome. Something I want to show you again that I forgot to mention is, if I go back to these commands here, right, and I look at this command here, this is quite interesting. If I just list the buckets, there's our state file bucket we created with the script. This is the one we created with Terraform. I mentioned that there was this one I created, you can see 2 hours ago. I created this test bucket. Did you notice that in Terraform, when it runs through the state, or I should say the state file, let's look at not the whole state file, but let's do a Terraform state list. You'll see in here the only bucket is this Tesla bucket, which is this one here. So, and the reason is because that's the one we built with Terraform. This is the one we built with Terraform. This came from a script. This came from the CLI I made 2 hours ago, and it will never be in the state. So it will only refresh, in terms of buckets, it will only refresh whatever has been written in Terraform. It will never refresh anything. So if there are modifications to this one made by me on the CLI, if there are modifications to this one made by script, also using the CLI really, or if there are new buckets added that are added by someone else, then it will never affect the world of Terraform that we have created, because it only applies to this. So that's something conceptually that you do need to get, you do need to understand, because as you saw before, when there's a change made, like we made for the VPC, we enabled DNS support, Terraform will tell you, and the reason is because it was already monitoring it. But Terraform won't tell you about changes made outside of these two resources. Okay, very, very important. Now, there's something else I want to show you. There's a couple more things I want to show you, and we're going to go back to the documentation. Actually, underneath every single document, right at the end, I'm going to scroll down. After the attributes that it said were available to be outputted, you got something here about what could be imported. Okay. Now, there's a couple of reasons that you would use this. Well, there's really only one reason. It's for the Terraform import command. So you can actually import existing infrastructure. Let's say you got a VPC with this ID. You can run this command and it will actually import that Terraform. I'm not going to try this right now. It's a bit beyond the scope of what I want to show you. It's not something you would do very often, but if you're a company, what can happen sometimes is, oops, sorry, that's the wrong thing. What can happen sometimes is, if I list all the buckets, then, and I list the state, then you can be building things in Terraform like these two resources, but you can discover, hey, wait a minute, what is this extra bucket here? What is this for? Do we need this? Okay, we need it. You know what? We better manage this. From now on, we better manage this in Terraform. And that is why you would use this Terraform import command, to import resources that are outside Terraform and bring them under Terraform management. That's why you would use that. Okay? That's the whole purpose of that command. So let's clear the screen. I want to show you one more thing, and it's quite an important one as well. And these are Terraform modules. So what I'm going to do is, to get this working, I'm going to move another file from to add, and it's called sg allow TLS. I will explain. I'm going to move this here, and let's have a look at this file. So there's a couple of output variables which you know what they are, ID and on. And this here is slightly different. It doesn't say resource, it says module. It's got a unique name. And instead it's got a source. And it says go into the modules directory and look for something called compliant SG. Okay, these are security groups, by the way. And then it says security group name is going to be this. So this is some kind of variable. And it's also referencing a VPC because all security groups are attached to a VPC. So this is the one we made earlier. Okay, so what's going on here? Now I want to show you what a module is. A module, and you can see it here, there's a directory. Let's go into it. A module, if you've used other programming, modules or libraries are isolated, separate, self-contained pieces of code that are reusable. Often when you want to redo the same thing but maybe give them different names or something like that. And it's for the same reason that they can be used in Terraform. So we have a module here called compliant SG, and I've called it that because in many companies what they will do is, if you just go start building buckets and VPCs the way you want using Terraform resources just how they're described on this page, they got a problem with that, because what will happen is they may fail, for example, security requirements. So there are some companies that won't even let you use these resources whatsoever. They will force you, or usually in most cases strongly suggest, let's say, to use company modules. And in this case what I've said here is, imagine you're a company and you've got here, this here is a module for a compliant security group. It's a security group that is, the code for it has passed the security department. Security department has looked at it and said, you know what, this is great. If you use this from now on, your code will always pass all our approval stages, no problem. Use this from now on, or even you're forced to use this. So let's have a look, right? We go in here, let's clear the screen and do a listing. This is a typical look of a module. And what you have here is a number of things. It looks similar but different, okay? Variables we're used to. And outputs, although we put our outputs with the resources, we could have put them in a separate file. So they're in separate files here. And main is just any old, main is quite common in programming, but basically in a module, all the resource code is in one file called main. So let's have a look at these. So if I go to main.tf, look at this. This looks super familiar. Resource, and then whatever it is. And then in this case a name, but it's called main. And then there's a name and a VPC ID. And it says here, variable security group underscore name and VPC underscore ID. Okay? But if you remember our original variables.tf file, right at the beginning of the demo that we looked at, we did not have sg underscore name. And we did not have VPC underscore ID. And I will explain that to you. Let's quit out of here. Let's have a look at the variables file. And there you go. It's actually defined sg underscore name and VPC underscore ID. And a little description, name of security group, name of the VPC associated with it, and it's got to be a string. Okay? So, they're defined here. Fantastic. Let's quit. However, where's the TFRs file? Right? There's no TFRs file. We're going to come back to that in a moment. Let's look now at variables.tf. Sorry, at outputs. So what it's doing here is this script will output the ID and the ARN. Pretty normal. However, it's going to output them with some very unique names, sg underscore ID and sg underscore ARN. We're going to come back to that. So let's quit out of here. That is the tour of the module. Let's go back up 2 levels. Let's clear the screen. We're back here. Okay, let's look at this code now for the security group. And you can see here exactly how this works. So it's referencing the module as was mentioned. And these here what were in variables.tf for the module. So this should make more sense now. So according to this module, in this location, it will be asking for this. So we're just like in programming with a module, library, or function, whatever you want to call it, you have to pass variables or pass parameters, and we're going to pass what it's expecting. It's going to be asking for this, and we're going to give it this manual name. I've just written this statically. I could, by the way, have put this in var dot in our variables.tf, and then we'd be saying var dot whatever, but I've decided here to just put it statically and call it set group, and just type it in manually. And for the other one that it's expecting, VPC underscore ID, well, we've made that VPC already, and I could type the ID in manually, the one that we got from AWS, this ID dash whatever. But we should link this up properly. This is better programming. So it's going to be this resource that we already have with this name and the ID of it, and that is what we're going to present to the module as the VPC underscore ID that it's been looking for. And look at this output variable. Do you remember the output on that module? The module was called SG for VPC 001, and we specifically designed an output variable called SG underscore ID, and also another one called SG underscore ARN. And this is what we're returning now. And we're actually giving it a new name. When we return it, we're going to give it a new name. But I hope you see how all this links up. Kind of looks complicated, but if you have 100 engineers and they all need to make security groups as part of their projects, and you're very concerned about standardizing how the whole company makes a security group and making sure that they're compliant and also just readable and done according to standards, then you're going to have modules. And in fact, although I'll show you here, our module was in a folder here, a directory right here, typically what you would do instead, you see, it's in just /modules. Actually, in the real world, you would have these in another repo, and you would reference the repo here with a repo URL, and that's how it would get it. And when you do it, and you'll see when we do it in init again, it will download the modules. So I'll show you. Look at this. Let's say I just straight away, let me clear the screen. Pretend I just wanted to just plan it straight away. All right, Terraform plan dash out equals plan file. Okay. And what you get here is module not installed, and you need to rerun Terraform init to install modules. So let's do that. So I could remove the old folder, but I'm not even going to do that. Let's just do Terraform init. Initializing the back end, well, the back end is the same. It's not too much of a problem. Initializing modules, you see that? It went into modules compliant SG and it grabbed that. And it knew to do that because it saw modules in our code. That's why. That folder was already there, but it never did anything with it, the modules folder. But this time in the TF code for the security group, it saw a reference to a module and it knew we need to initialize these modules. So that's what it just went out and did. And if those modules were in a repo, it would have done the same, but it would have actually downloaded them from the repo. It would have taken a lot longer, but this is local, so it was super quick. So init has been successful. So let's do a plan. Let me clear the screen. Let's do that plan again. We're used to this, acquiring the state lock. That's normal. It should be refreshing the state. There we go. For what it already knows. And let's just scroll up. So it refreshed the state for the VPC in the bucket, just in case changes were made we didn't know about. And from the code, it knows that there's this new thing has to be created. It's a resource security group. And yep, all this stuff here. And plan 1 to add, 0 to change, 0 to destroy. Okay, so let's do that. Let's do the plan file. Let's apply it. Terraform apply plan file. So it shouldn't make the plan again. It should see our plan file and ask to execute it. And it's doing it. It's creating the security group. It made one resource, and there you go. And it updated the outputs. And obviously we have some new ones. We have 2 new ones here. SG for VPC, and it gave us. Yeah, I didn't mention this before, but this is a typical AWS ARN. It looks like that. very typical, starts on AWS, and you know, IDs will typically start with the resource dash. So it gave us 2 new ones. This is exactly what we asked for. The module worked fantastic. Let me show you, by the way, have a look at Terraform state list and see what's in the state file now. And there you go. We had the first 2 already, and we now have this one here. So you see, it's actually listed slightly differently. Because it's a module, it prefixed it with module dot, and yeah, that's how it works. So we called our new resource this, but the actual resource within the module is that, and yeah, within the module that was called main. So there you go. That's how to use modules. I don't like to. Sometimes modules are more complication than they're worth, and I think there's a lot to be said for just using resources. But you will have to use modules, and they do definitely have a very good use case, and they are widely used. So you need to know, if you're using Terraform in a company, you definitely need to know how to use modules. And I thought I would show you a super simple example. So yeah, I hope that was very clear. So something else that I'm going to do while we're here is, you don't really need this for learning Terraform, but as you can see, I do have a script here, and this is supposed to destroy everything. So let's well, it's supposed to destroy the state file bucket. Let's do a Terraform destroy first of all. Let's see if this works. This will take a few moments. So we want it to destroy 3 things. So refreshing the state for 3 things: VPC, bucket, and the security group. And it should say 3 to destroy. I'm not even going to check the rest. We know what those 3 things are. Not good practice, really. You should really inspect it, but you know, this is just for demoing, so I'm not worried about it. And there we go, everything destroyed. Now we're still left with a state file bucket. So as I said, I made that script. So let's try this, because this script should work for you as well if you want to use that, if you want to clean up after making your remote bucket. You don't have to. You may want to keep it and keep reusing it, but if you want to destroy it, then this should hopefully work. So let's see. Now it is a little bit janky. It is going to show some errors. I have not modified the script to suppress the errors, but these errors are not really errors actually. So yeah, the reason you get all these errors is because it's super difficult to actually destroy a bucket in AWS. You have to actually turn off versioning, destroy the versions, destroy all the objects, etc., etc., etc. And I believe that has worked. So if I just go to my commands here, and we want to list the S3 bucket and also the DynamoDB tables, then if I then do a insert there, and we should get some output back. That's the test bucket I made before, so you can just ignore this. It's not relevant. And there you can see the no tables anymore. So the destruction was successful. That's great. By the way, this here is just a command to describe your VPCs and security groups. In case you wanted to see the relationship between VPC and security group, you can just do that in the UI, but I did have a command for it. I just never got around to using it. So let's go back now to here, and that's the demo. So I hope you enjoyed the demo. Please, we're not finished yet. There's a little bit more. By all means, take a break and pause, but at this stage I just hope you're enjoying it. This is a new channel, so please like and subscribe. And that's a summary of all the commands that we used. So there are more, but these are the most important ones that you can use. So there's the list, and really, if you know this, you know 90% plus of Terraform. You don't need anything else. Everything that we've covered in that demo, you're set to go. So there were some other remarks I wanted to say is always tag your infra. I did mention that before, and sometimes there's a default tagging available with your cloud provider or the Terraform provider. Terraform init, it can take a long time for big and complex infra, so just bear that in mind. Sometimes you can get in the habit of just running in init quite often, you know, when you don't really need to. And if you're on a big infra, that's not a good idea. Another thing is use a flat structure for your code. We called a module, but what you can do is you can call a module that calls a module. Okay, now that is okay as well. There is a use case for that. But if you call a module that calls a module that calls a module, and another module. It's just a bad idea. It's the same thing for nested variables, which are variables within variables. Now remember, our variables were just strings, simple strings like region and I think one was a sitter block. What you can do, let's say you have 10 variables and they're all strings, you can actually make kind of like a list and just have a list of 10 strings. And you can go further, right? That's one-dimensional. A list is a one-dimensional array. You can have like a 3 or 4-dimensional array if you want. Bad idea. I've worked in companies where they were managing an entire infrastructure of dozens of different pieces of infra, and there was only one variable, and this variable was multi-dimensional and was full of parameters, and it was full of assignments, and it was such a bad idea. It was hell to debug that. It was complete hell working with it. Don't do it. Trust me, just don't do it. These 2 points are very opinionated, but that is my opinion, and in my opinion, don't do it. Okay? Other people may disagree. What I didn't cover just now was you may want to do some research, do some Googling, locals, workspaces, loops, conditionals. These are not uncommon, and you may want to have a look. As I say, they're not uncommon, but I didn't want to make the video too long. Don't put your entire company infra in one repo. Some companies do this, or what they do is maybe they'll split it out by department or something. But in my opinion, it's just a bad idea. I recommend to split it out and decouple it. It means that when your multiple engineers are working simultaneously, you won't get in each other's way. It means that sometimes, occasionally, you'll get a Terraform error when you'll be like, well, wait a minute, when I'm doing a Terraform plan, I'm expecting it, coming back to this after 3 months, it should say nothing to change, but sometimes you'll get an error and it will hold up your work. If you split out your infra, you're less likely to be blocked by that. So that is my recommendation. Again, it's a matter of opinion. It's also normal, as I mentioned, to put modules in their own repo. That is pretty much standard, or at least on a file share if you're not using cloud buckets. But better to use a bucket. Sorry, I'm getting confused with state. Always use a repo to put your modules in. Now pipelines are quite simple. I'm not going to construct one, but if you've got a CI/CD pipeline, it will pretty much just have those commands: Terraform init, Terraform plan out equals plan file, Terraform plan file. And you might also have format, validate, stuff like that. The key thing is that whatever you do, make sure that when you do a pull request, merge request, that there's a Terraform. The pipeline should run even when you create the pull request. And it should show, for the code reviewer, it should show them a plan beforehand. And that way, they do have to inspect your code, but they'll be reassured immediately that your plan actually has no validation problems, and it will confirm to them how many resources will be created, modified, destroyed, and what those creations, modifications, destructions will be. Okay, so I strongly recommend having the plan visible, and it should run on the runner and be visible as part of the ready to be approved pull request. That's what most people do. And there may be tools to help you with that. You can do some research. Do code reviews. I just mentioned that already. So I've actually worked with multiple engineers where all we would do is just Terraform apply by hand all day, until I met one senior engineer and he was like, guys, you should be doing it the developer way, creating a pull request and getting these approved, getting these inspected first. Someone can check them, and then either they approve it, fantastic, and the pipeline will normally apply, or they will come back to you and say, I think you should correct X and Y. I think it would be better like this, and after that I'll approve it. So I strongly recommend you do that. I'll just give you a preview, by the way, of an example of that. So if we look at my repo, here, so far I've been using the develop branch. If you're not used to doing code reviews, then what you would do is you would go, and it's slightly different in different Git providers, but here I would go new pull request, and I would say I want to merge from develop into main, okay, and then it will show all the commits I've made. And by the way, I'm using something called conventional commits, which at a glance tells people what I'm doing, and they can see all of those things. They can expect individually all the different commits, and they can see the diff on every single file that I've made. They can see a diff, so super useful. well, I should go new pull request, okay? And normally you would say please you would say please approve, but I'm typing a bit badly there, but you would say please approve, but you would also really put some explanatory notes there and not just please approve. That's not very good. And then you would create the pull request. It would create a link. You send that link to the approver, and maybe you sit together and go over it, and then they will hopefully approve it. And ideally, your pipeline will just also do the apply. If the pipeline doesn't do the apply, then you will just do it manually after. But this is how you have a repo as a single source of truth. You have an audit trail of who's approved everything, etc., etc., etc. So that's that. Let me go back to the slide. And there's also a couple of so do code reviews. There's some additional tools as well. So for version switching, these two tools are the most common. There are others, but have a look. TFN, TF switch. In reality, different pieces of infra will be managed with different Terraform versions, and you don't want to accidentally use the wrong one. If you use these tools, it should recognize it, or may need to do some small configuration to recognize it and not use the wrong one. The reason is that you need to use the same Terraform version as whatever it was used last, which is shown in the state file. If you forcibly upgrade or downgrade the state file, it can lead to issues. Basically, you can get corruption and all kinds of issues. And also, newer versions of Terraform will support new features that the older one may not have. So, very important to do version switching. If you're learning, don't worry about that for now. TerraGrunt is an overall, it's kind of wrapper that goes around Terraform, and it's very popular. I actually haven't used it, but I will be testing it out. I might do a video on it. It does a lot of different things, and it's super common. Basically extends the functionality of Terraform. However, although it helps you manage things, arguably it makes things more complex as well. So there's a trade-off there just to be aware of, okay? And very quickly, the alternatives to Terraform. You've got OpenTofu, which is new. Terraform changed their license recently. A lot of people weren't happy with it. OpenTofu is open source alternative. It's gaining traction. A lot of vendors have even said that they're going to support OpenTofu instead. CloudFormation is AWS only, but it's only single cloud. It's inferior to Terraform. It doesn't handle state very well, which is the really amazing thing about Terraform, that it does and almost nobody else does. Pulumi is like more programmatic version of Terraform and can also be used in multiple clouds. But try hiring an engineer who already knows Pulumi. Super hard, whereas most people know Terraform. You can also, with a cloud software development kit, use a programming language like Python or some other programming language. And just like Terraform, it will use API calls in the background. So super cool, but there's no concept of state. Or you can even do direct API calls from a program to the cloud provider. No reason why you can't do that. You could even make your own version of Terraform or your own CLI if you wanted to. There's something you might see called CDKTF. This is kind of like a programmatic version. You can use Python to program Terraform, kinda. It's a bit of a bad description, but go ahead and Google it. What I want to tell you is it's losing traction in terms of it's losing adoption. Apparently it's buggy. I've never used it, but I've heard it's buggy. It has low adoption rate and other issues too. So check it out, do some reading, but I would say you don't want to use it. I've learned enough about it that I won't be using it, but I may revisit it at some point. I rarely see it advertised in job ads. I see CloudFormation, I sometimes see Pulumi. Cloud SDK, they don't always talk about it, but it's very commonly used. Sorry, one more thing. Common interview questions that you might get. What is a module? This is very common. I've tried to summarize it in a sentence that you can just memorize because it's a lot easier. Otherwise, you're liable to just babble on and on. A Terraform module is a reusable, self-contained package of Terraform resources. It can be called like any other programming library or module. Another question you might get is, what is the difference between count and for each? These are both used for loops and for iterating and producing multiple resources, typically VMs in an auto-scaling group. Go ahead and look at that. Count came first, for each came later. It's improved and has fewer limitations. That's a clue, okay? What happens when you do a Terraform init plant apply? I think we explained that super great detail, especially about refreshing state and those kind of things. How to target a resource. So there is a command called -target. And what you can do is you can say, right, I don't want you to look at all of my Terraform infrastructure, but just look at only one or two resources and ignore the rest. It should only be used urgently or if you're debugging, because what it means is that you're in ignorance of everything else, and if you keep using this for days, you may have drift that you're not aware of. So I strongly advise against using it, and if you do, be cautious and only use it for urgent cases or debugging. And to be honest, even in an urgent case, I'd be tempted to tell the manager, look, I'm not going to just hack this thing, I want to do things the correct way. Do it in code, have someone approve it, do a pull request, instead of getting on the command line and doing Terraform apply with a target. Sometimes people need to be told that if you're going to do IAC, you're going all in, do it properly or don't do it at all. So that's it. I hope you really liked this video. It was a long one, but as you can see, it's pretty much everything that you need to know from zero to hero. Please, if you didn't do already, like this video. We're new, subscribe as well. We're very new, so yeah, I'm hoping to grow and explain things, real world examples, summaries like this, everything that you need to know. Really hope you like this video. Come back for more, check out my other videos, and I will see you later soon. Take care, bye bye.